Your markers whenever you're ready.
Great. Thanks, Teresa. Hi, everybody. Great to be here as part of the Funding the Commons, Earth Commons Hackathon 2024. I'm going to be sharing a little bit about ecological benefit assets today, in particular focusing on carbon markets. But I'll preface by saying that a lot of the concepts I'm explaining here do apply to other ecological assets. So if you're developing biodiversity credits or plastic removal credits, a lot of the same concepts and frameworks that I'm going to run through will apply there as well. So I'm here in Florida right now, where we just had two severe hurricanes back to back. And I think it's pretty clear to everyone with the flooding in Thailand, with an ever increasing number and frequency of natural disasters occurring all around the world, that the effects of climate change are here already. And Earth's climate is destabilizing rapidly as we continue to force more carbon in the atmosphere through emissions and other activities that are pushing our planet out of the stable equilibrium that we've come to know and love as humans. So before I get into it, I'm just going to give a brief overview of the agenda here. I'm going to spend about 15 minutes talking about carbon markets and how they work. Then I'll run through a few examples, one from DeFi and one from an NFT project. These are going to be pretty technical. I'll go through the code as well as how the applications themselves work. And then I've left about 10 or 15 minutes for John to go through how Astral Protocol works and talk about location-based proofs. And I've also left a little time at the end for Q&A. So as I was describing, we all rely on a stable climate. For all of human history, the Earth's temperature has been in a fairly narrow range, and we haven't had any global catastrophic climate events like an ice age or a major volcanic eruption that has caused extreme instability in the climate. Now, with the forcing function of greenhouse gas emissions, deforestation, and other negative environmental impacts, we are, as a species, destabilizing the climate of the planet that we call home. And this is creating problems all over the world. But in particular, there's a useful analogy for how to think about this issue, specifically around greenhouse gases and carbon dioxide emissions. That systems thinking model is pretty well understood, widespread, is the bathtub model. And the basic idea is that our atmosphere is a bathtub. We have been filling it up with carbon dioxide in the form of greenhouse gas emissions. And there are also mechanisms that remove water from that bathtub, both natural and artificial. But the real thing causing global warming, leading to the increased severe weather events, the higher average temperatures, is the CO2 in the bathtub. So there's really two different ways you can think about attacking this problem. We need to both reduce the rate at which we are filling up the bathtub, i.e. turn off the tap of emissions, but we also need to bail out water from the bathtub if we're going to stabilize the Earth's climate. For context on the amounts here, we're emitting about 40 billion tons of carbon dioxide every year, and the bathtub contains about 2 trillion tons of carbon dioxide in excess of what was there before the Industrial Revolution. So we're emitting a few percent every year. We're filling the bathtub by a few percent every year. And we're not really bailing out the bathtub much at all right now. There are some natural sinks that are removing carbon dioxide at about the same rate they always have been. Things like the ocean absorbing CO2 in the form of carbonic acid, rocks weathering that absorb CO2 from the atmosphere as well. But those effects are pretty small compared to the rate at which we are adding CO2 to the bathtub. So we need to both turn off the tap and we need to start bailing out CO2 from the proverbial bathtub. In the context of carbon markets, we talk about these two different activities as reducing emissions or removing emissions. So reduction is some activity that will stop emissions from going into the bathtub in the first place. For instance, switching from a coal-fired power plant to renewable energy, or switching from a gas-powered car to an electric car. On the other hand, removing emissions is some activity that's going to take CO2 that's already up in the atmosphere and put it somewhere where it's stored for a long time. So for instance, if you plant a bunch of trees, make sure they grow up to be a strong, healthy forest, you're now storing carbon in the wood of those trees. Similarly, if you create a factory that sucks CO2 out of the air and puts it underground in a storage location, that's also going to be removing emissions from the atmosphere where they won't be able to have the impact of capturing heat from the sun and warming the planet. So these are sort of the two key types of activities. In the context of the bathtub metaphor, a reduction is going to be turning off the tap. A removal is going to be bailing water out of the tub. And there are two different mechanisms for incentivizing these kinds of activities. On one hand, you have a government mandated system, also known as a compliance system, where the government says, for instance, we will not allow companies in our jurisdiction to pollute more than X tons, to emit more than X tons of carbon per year. And if they do put out more than X tons of carbon per year, we're going to put a very harsh fine on them and make them pay the government for that violation. On the other hand, there is a voluntary market. I also like to call it a verified market, because rather than the government mandating that a particular activity cannot take place, and if it does, they fine you, in a voluntary system, individual actors are going and taking positive actions like planting trees or switching to renewable energy. And on the other side, individual actors are paying those project developers, those producers, for the activity that they're carrying out. I'm going to focus on the voluntary market. The reality is that these two systems are actually kind of intertwined, and some compliance market systems are now integrating credits from the voluntary system, but that's a bit out of scope. It goes beyond the sort of simple introduction that we're here to discuss today. But if you have questions about compliance markets, feel free to reach out to me on Telegram or Discord. So in the context of the voluntary system, what we're trying to do is basically pay people to go out and turn off the tap, or pay people to go bail water out of the tub. Those people that are going to go do the work are called project developers, and they're running companies all over the world that go and take some positive action. This is a bit of an overview of how the carbon market is structured and the different players that are acting. It's quite simplified. There are other players involved, but these are the key types of actors and their relationships. So I just mentioned the project developers. They're really the stars of the show here, because they're the people who are going to go out in the real world, put shovels in the ground and actually do stuff to have a positive impact. Now, they may be implementing different activities, and I'll go into that more later, but the point is they're going to go do something. And then the other players are there to support the activities that the project developer are carrying out. So most importantly, the buyer is the one who's going to be financing this activity, right? Because going and planting trees or installing solar panels, that all costs money, and the money's got to come from somewhere. And in the context of a voluntary market, we talk about buyers, or also known as retirers. These are the people who are going to be consuming the underlying credit and supporting the project developer with cash, with money. On the other hand, you have the VVBs and the registry. And these play an important role of checking that the project developer is actually doing what they said they were going to do, and that it's being carried out according to the appropriate scientific methodology. So on one hand, we have a carbon credit registry. These are organizations like Verra, Gold Standard, Puro Earth, and their job is to publish standards for what a good carbon credit looks like, as well as have a system of record where those credits are recorded, the projects are, information is stored, and when a credit is actually issued, all the transactions are going to be taking place in the carbon credit registry's underlying ledger, in their underlying transaction log. On the other hand, we have VVBs, validation and verification bodies. And their job is literally to go and check, did the project developer do what they said they were going to do? And did they follow the standards set out by the registries? So in the traditional carbon market, these VVBs are literally sending people out into the field with clipboards and tape measures, to look with their eyeballs and check, like, did the project developer actually plant the trees? Are these solar panels actually installed and hooked up to the grid? And then they will publish a report back to the registry, which includes information about what they saw when they visited the project, maybe some photographs, basically attesting to the legitimacy of the project developer's activities. So that's a bit about the structure of the market and the key players. And I want to just emphasize that these players are typically independent from each other. So the VVB is a third party, usually a consulting firm. Project developers are usually companies that are locally based in the jurisdiction where they're operating, or they work with an on-the-ground implementation partner in the jurisdiction where the project is being implemented. And the carbon credit registries are typically NGOs or nonprofits that basically function as standard setters, and they don't themselves go out and develop projects directly. So I want to talk a little bit about methodologies and the different types of methodologies and how they relate to each other. So some of the most common ones that you'll encounter are things like planting trees, also known as afforestation. That's where you take an area that either is not currently forested or was previously forested, but it was cut down, and you replant those trees. This is a type of removal activity, and it is one of the most popular and widely deployed methodologies. It's not necessarily the quickest. These have quite long turnaround times because trees take a long time to grow. And there's sort of trade-offs in each of these methodologies between the speed, the profitability, the effectiveness, and there are various attributes along which each methodology can be assessed. Another methodology that you've probably heard about is renewable energy installation. I've already mentioned that. And this is where you go and install a solar panel or install a wind farm, and you are calculating the credits that are issued for these methodologies based on the avoided emissions that would have taken place if the grid did not have these additional renewable energy resources. So these are typically implemented in jurisdictions that have a large reliance on fossil fuel energy. So for instance, developing countries like India, Turkey, China have been some of the most widely deployed locations for renewable energy-based carbon projects. And finally, we have industrial projects of various forms. So on one hand, you could improve an industrial process by, that reduces emissions, for instance, by destroying a very toxic or highly potent greenhouse gas before it's emitted, or improving industrial process so that it consumes less heat, or a factory that actually removes carbon. So for instance, you've probably heard about direct air capture, where you literally build a big factory with fans on top, they suck in a bunch of air, separate out the CO2 using some chemical or mechanical process, and then store that CO2 underground. And each of these activities has a scientific document associated with it, a methodology. Kind of like if you were in a science class in grade school, they would give you a methodology with like 5 steps where you're going to carry out an experiment. Similarly, a carbon credit methodology is basically a step-by-step guide for how you carry out a particular activity. And most importantly, which variables you're going to need to measure in order to confirm that your activity actually had the intended effect. Whether that's, the size of the trees that you planted, or the amount of CO2 being measured by your flow meters as you're, capturing it out of the air in a direct air capture plant. The methodology lays out the steps to take and the variables to measure to confirm that those steps were actually implemented correctly. So stepping back from the mechanism I just laid out, this whole system was developed in the 1990s under the Kyoto Protocol. So the first ever carbon markets were something called the Clean Development Mechanism, developed directly by the UN and administered by the UN. But there were some issues that emerged with that initial implementation. And we're currently living in a sort of carbon markets 2.0 world. The current generation of registries that I mentioned, Vera, Gold Standard, et cetera, they came up in the late 2000s, early 2010s. And the tech stack really hasn't evolved much since that time. So we're talking phone calls, emails back and forth, wire transfers to send money, PDF documents as the authoritative records for these activities. And there's a big opportunity here to improve the scale of this market by addressing the tech stack, by basically upgrading some of the technology being used for various aspects of this market. Because the reality is that this market is quite small. I mentioned the 40 billion tons per year number and the 2 trillion tons total emissions since the Industrial Revolution. There's only been about 2 billion tons of carbon credits created using this mechanism since it was created in the 1990s. So we're really talking about a few percent of annual emissions over the past 30 years. And if this market is going to have a meaningful impact on the climate crisis and help us stabilize the climate, it has to grow a lot, like 100 to 1,000x over the next couple of decades. And in my opinion, the current tech stack is not going to scale to address that. Is not going to scale to that level. So we need to do some upgrades. And on one hand, there's a lot of manual processes going on here and a lot of opaque operations. That's not only slow and inefficient, it also opens up opportunities for fraud and abuse. But there's some modern tech that's been developed in the last 10 years or so that I think can solve most of these problems. In particular, I'm going to talk about 2 different aspects of this issue. I'm going to talk about some supply side issues around the way projects are implemented and verified, as well as some demand side issues around how the credits are traded and consumed. So basically, my point here so far is that this concept is sound. We need to both slow the rate of emissions and bail water out from the tub. And this mechanism of carbon markets provides a way to fund people going out and taking those actions. But the implementation as it currently exists is flawed and imperfect, and it can be improved by applying some new technologies. So on the supply side, meaning project developers are going out and doing something, and they need to do that in an effective way and monitor what they're doing in as high integrity and also high efficiency ways they can to reduce their costs associated with verification. So there's a movement now from the traditional MRV, or monitoring, reporting, and verification process that I described before, where a consultant flies in, they have a clipboard, they go around with their eyeballs and they look at stuff and they write down on their clipboard what they see, and then they send a PDF report. That's the traditional MRV process. DMRV, or digital MRV, promises to address some of these integrity and efficiency concerns by leveraging modern technology. Think instead of sending someone out with a clipboard and a tape measure to measure the amount of trees that have been planted and how big they are, you use satellite data to assess the amount of biomass in a particular area. On the other hand, you might use in a factory context, you might have gauges, like physical gauges that you like look at with your eyeballs, instead of having a consultant come out and look with their eyes and write down what they see on a piece of paper. You could have an IoT device on that gauge that publishes a cryptographically secure record of the measurement that it took onto a public blockchain. And then that becomes the system of record that you can then use in your MRV calculations to determine how much CO2 was captured by this DAC plant. On the other hand, you also have soil projects, so where you're trying to change the way that an agricultural process is carried out, for instance, to capture more carbon in the soil. And currently, those soil measurements are quite expensive to take because you literally need to go send someone out, dig a little hole in the ground, and then send that soil sample off to a lab somewhere remote where they're going to carry out some manual tests on that soil sample. But there are people developing IoT devices that can be embedded directly in the soil that can assess many of those soil parameters without having to physically remove a sample and send it off to a lab somewhere. So in my view, DMRV can address many of the integrity concerns while also enabling project developers to carry out smaller and more cost-effective projects because you don't have to fly someone out from the Western world to come and look with their eyes or take physical measurements in the same way. You may still need some ground truthing. There's some, back and forth in the community about to what extent you can rely on, purely remote sensing for assessing these projects. But I think that you can move from a world where 100% of the verification is done manually by someone, physically visiting the site to a world where maybe 90% of this verification is done through remote sensing. And then you periodically send people out to do spot checks or have some other mechanism for ground truthing the methodology and making sure that the remote sensing measurements are accurate. So that's the supply side. And frankly, I personally do not spend much time working on the supply side issues. They're pretty hard science, deep in the weeds issues. I'm more focused on solving some of the demand side issues in the organizations that I work with. And there's really a big unlock that addresses, in my view, most of the problems on the demand side. And that is tokenization and more generally web-based technologies. So the way that these credits are typically traded right now is very opaque and very cost intensive. So if you want to get your hands on, say, a direct air capture credit from Climeworks, you're going to be calling somebody on the phone, sending an email back and forth with them. And by the way, if you want to buy less than like $10,000 worth of this stuff, they're probably going to hang up on you because in their view, the amount of time that it takes to fulfill this order, to send the wire transfer is simply not worth it if they're only going to be, doing a transaction of $100. In fact, sometimes the transaction costs themselves can be as high as $100. So if you wanted to, say, offset a flight that you took to Thailand to go to DevCon, there's not a lot of brokers that want to talk to you about that because your total cost is going to be somewhere in the range of like $10 to $100. And it's just not worth their time if they have to take a call, send an email, do a wire transfer, email a PDF. So tokenization can solve many of these problems by simply taking the credits from these opaque Web 2 systems where they're require permissioned access in order to use and put them into a more open, public, interoperable ecosystem that is a public blockchain. So there's really three aspects of the demand side that can be improved through tokenization. One is improving access, as I already mentioned. Another area is improving automation. So rather than having to go and click a button when you want to retire a carbon credit, you can build an automated API that every time a widget is manufactured or a flight is booked, a small amount of carbon credits are retired. And we can also get money more directly into the hands of project developers. So rather than the project developer having to sell their credits off to a broker who then sits on the phone all day taking orders, the project developer could directly list their credits for sale on a marketplace and capture nearly 100% of that transaction for themselves. So there's work to do. There's a lot of stuff to build. There's a lot of problems to solve. And I'm going to walk through for the rest of this session a couple examples of how people are solving some of these problems. So this is a similar slide to what I just showed in terms of the structure of the carbon market. And I've added a few logos here to indicate how some of the sponsors involved in the hackathon are playing. So on one hand, I've been talking about the demand side just now, right? So KlimaDAO on the right-hand side, we're really trying to solve the process of getting money from a project financer, from someone who wants to buy the credits, to the project developers more directly by creating a liquid spot market for carbon credits. And we also do some project financing ourselves, where we directly fund a project and take the credits for sale in our market. We work closely with tokenizers like Toucan Protocol, who work with the registries to create a tokenized representation of the off-chain asset, so that then we can plug into all these interoperable Legos like, AMMs and other DeFi primitives. And then we have organizations like Astral Protocol that are working closer to the supply side, where they're building solutions to monitor the projects, to provide location-based proofs about the activity that took place in the real world. You'll hear more from Astral here in a few minutes, but first I'm going to walk through a couple examples of how carbon credit retirement has been embedded into on-chain applications. So just before I get into that, a couple real world examples of how carbon credit retirement is already being used in the real world, off chain. So on one hand, you probably already see this when you book flights. Occasionally, you'll be offered an option to offset your flight. Basically, what's happening on the back end is they're collecting a bunch of these orders, calling people on the phone to settle them, and usually like once a month or once a quarter, they'll actually retire credits. On the other hand, you have manufacturers that want to compensate for the emissions associated with their manufacturing activity. So one of the organizations that I work with, Carbon Mark, is partnering with a battery manufacturer for EV batteries who want to make truly net zero batteries. So they calculate the emissions associated with sourcing the minerals and producing the battery in a factory. And then they compensate by retiring carbon credits so that those batteries are not just reducing emissions from the ICE engines, the gas guzzling engines that they're replacing, but also they themselves have a carbon neutral life cycle. Similarly, when you're booking an Uber, you may be offered an option to take Uber Green, and they will retire carbon on your behalf for the ride that you took. Package delivery, similar idea. And really the emphasis here is that by putting the carbon credit retirement closer and closer to the underlying economic activity, we are surfacing the emissions intensity of that activity directly to the consumer. And then it becomes a cost. It becomes a question of, do I want to take the train instead of the plane because it, costs me less in terms of the carbon that I'm emitting? And it also puts foregrounding in people's mind how emissions intensive is the activity that I'm carrying out. Maybe I could just go to the grocery store and buy this item rather than incurring the 25 kilograms of emissions that the shipping is going to have associated with it. So the idea in a nutshell is integrate carbon credit retirement, integrate the emissions impact of a given economic activity into the cost of that activity. So as an example, moving to the on-chain world, KlimaDAO worked with SushiSwap last year to develop what we call the green fee. And the idea here is that every time a user engages in a swap on the SushiSwap platform, a small amount of carbon credits are retired. Now, there were a couple unfortunate aspects of this specific example. It's just the best example I have to demo. In particular, I recently found out that it was deprecated off of the production SushiSwap application. So I'm going to be walking through the source code and some of the documentation here just so you have a sense of how it works. But this is a really generic concept that could be applied to other DeFi applications. It's just a useful example for us to go through. So I'm going to jump into the source code in a second. I just want to quickly walk through the components that are going on here because there's like 5 different files we're going to be navigating across. So on one hand, there is the Sushi router itself. And this is, you're familiar with if you've ever done a swap on Sushi or Uni or any other DEX. There's a router that decides which specific LP pool to swap through based on the input token and the output token. And basically the way this feature is implemented is that there are 2 different router contracts. One is the normal router. That's the one up here. It's sort of the default, works exactly as you would expect. You put in your input token, you get out your output token. On the other hand, the user can opt in by basically clicking a flag on the Sushi UI, can opt in to a green router. And what the green router does is it basically has a couple extra lines that send a little bit of gas token. In this case, it's Polygon, so it's POL token, gets sent to a separate contract. This extra gas gets sent to a separate contract called the swap retirement holder. And that swap retirement holder has a function on it that will basically retire whatever gas has been accumulated. It will swap that gas token POL for carbon credits, and then it will retire those carbon credits using the KlimaDAO retirement aggregator. And this whole mechanism is automated using a chain link automation that once a day calls the perform upkeep function on the swap retirement holder to actually initiate the retirement of any accumulated fees. Okay, so that's sort of the structure of how this thing's going to work. I'm going to flip over now to the source code. So there's a link to this in the slides, and there's a URL in the slides that's easy to find, so feel free to follow along. So here in the KlimaDAO Solidity repo, I'm going to start by looking at how the Sushi router itself works. So this is the SushiSwap green wrapper. This is the modified router contract. And the most important thing that's going on in here is we have this function called green swap tokens for tokens. And all this does is it calls the same swap function from the main router contract. It's importing the interface for the Uniswap v2 router, calling the swap. And then right after that, we send the native gas token. A little bit extra was collected from the user, and we send that extra over to the retirement holding address, which is that swap retirement holder contract I mentioned earlier. And then if it fails to send, we just emit a requirement. So that's pretty much all that's going on here. We added 2 extra lines that send a little bit of extra gas to this retirement holding address. And then if we go over to the swap retirement holder contract itself, in here, there is a function called perform upkeep. And this is really where all the action is happening. In this function, we're basically going to check if we've done another retirement recently. If it's been sufficiently long since the last time we did it, if it's been longer than the interval, then we will carry out a retirement. And basically, we compute all the retirees that need to have a retirement done on their behalf. And then we call the Klima retirement aggregator retire carbon function. And we're passing in basically the carbon token that we want to retire, as well as the fact that we're using the native asset of Paul, plus the amount to retire, and some information about the retiree. And then we fill in what's called the retirement beneficiary and the retirement message with these SushiSwap green transaction and retired using KlimaDAO X SushiSwap integration, just so that there's information on chain about why this retirement took place and where it came from. This is really important if you're going to be doing an integrated carbon retirement, that you think about who is the beneficiary, like who is going to claim this underlying benefit, and what message am I going to put so that it's clear why this retirement was carried out. Okay, that's really the meat of it. And then the only other thing that happens is there's a chain link keeper that is going to call that perform upkeep function. It's pretty straightforward, standard chain link keeper logic. You basically configure the contract address that it's going to call, as well as the function and any parameters that need to be passed to that function. And you do that through chain link automation. You can consult the chain link docs for more information about that. It's pretty straightforward. And that's basically how the SushiSwap green fee works. I am going to just quickly show you how it used to work because it was deprecated recently. So basically you would come in here, you're on your SushiSwap trade page, and basically under the extra settings, there was a little flag that would say like green fee, and it was opt in, which was one of the things we went back and forth with them about, because we really wanted it to be opt out, so that by default all SushiSwaps would have this additional fee. It was really a few cents. I think we were doing 5 cents worth of Matic or Pol. But yeah, they wanted it to be opt-in. I kind of understand why, but on the other hand, it's something to consider when you're implementing one of these retirement functions, that there should be a good reason why it's opt-in or opt-out. And obviously opt-in is going to be more deferential to your users, but also fewer users will do it because, as we know, basically humans are averse to taking actions. So anything they have to do, any extra clicks they have to do to make this happen is going to discourage people from actually using it. But yeah, that's basically how the sushi green fee works. And the sort of more abstract or more general concept here that I'll emphasize is anywhere where you have a DeFi application doing some transaction, there is an opportunity to integrate carbon credit retirement into that transaction in a pretty straightforward way by adding a couple lines of code. Okay, so now I'm going to move on to NFT strategy examples. That was a DeFi example. Now we're going to look at some NFT stuff. So there's basically 2 different strategies that we've seen most commonly adopted by NFT projects. One is where you simply retire a batch of carbon at mint. This could either be done as like a one-off transaction by the collection creator, or it could be done where in the mint contract itself, you have that retire carbon function similar to what we just saw with the sushi green fee. where basically you collect a little extra or you use a portion of the minting fee to retire some carbon. Another idea, which is a little more interesting, is to embed live credits, so unretired carbon credits, into the NFTs themselves, and then have some mechanism where users can, either add more carbon or retire the carbon that's already in the NFT tokens. So there's a few different ways you can imagine doing this. We've talked to some game developers who wanted to have, a certain NFT that represents an in-game object, and like for instance, a tree. And if you water the tree, then it retires some carbon or something like that. Some mechanism where the user interacts with the token and it results in carbon being retired. We wrote a whole blog post a while back about these different NFT strategies. So if you want to learn more about that, I encourage you to check out this blog post. Like I said, the slides are going to be linked, so don't worry about frantically typing this URL in. But I want to go through a specific example of an NFT project that uses carbon credits, and that's a project called Plant-Based. Let me actually go back. Okay, so a project called Plant-Based, and this is on the base chain using Toucan Protocol's new biochar-based carbon pool. So the website is plantbased.art, and they've also got some of the GitHub code provided by our friends at Toucan that I'm going to walk through briefly. So this is the landing page for Plant-Based. It's a regenerative art series that evolves as you store carbon. So we'll just play the little intro. Cool. So there's a few different functions here. Obviously, you can mint the thing, and when you go to Carbon, it links you out to a page developed by Toucan themselves. And basically, the idea behind this collection, as I understand it, is that users who hold the NFT itself can put char into the NFT, and then at some point, they're still working on this. There will be an ability to retire the char that has been accumulated in your NFT. And over time, as you add more char into the NFT, it modifies the NFT. Yeah, that's basically it. And this function or this collection is using an underlying function created by Toucan that they're calling the NFT carbon extension. And basically what this does is it manages the carbon holdings of the NFT. So, users can call this contract to add carbon into the NFT. And there's also going to eventually be a function for retiring carbon out of this NFT. As far as I know, that hasn't actually been implemented yet. But one of the good things about this is if you're putting live carbon into an NFT, I would just be careful and consider how the carbon is going to be either extracted from the NFT or retired. Because one thing you want to be careful about is not pitching the NFT itself as like being a carbon credit, because there's a lot of concern, rightfully so, in the carbon markets about what's called double counting, where the same carbon credit is being used to make a claim that like I supported removing 1 ton of carbon through biochar dispersal, but then the credit hasn't actually been retired, and then somebody else gets a hold of that NFT, and then they somehow get the carbon out and retire it. Then they're also making the claim that they removed 1 ton of carbon from the same credit. And that's very dicey. I highly discourage you from doing that kind of thing. You always want to be thinking about, if the credit is live, how am I eventually going to retire that credit? Or if it's going to be put in there retired, how do I make sure that users are not making multiple claims? Or I should say that multiple users are not making the same claim based on the same retirement. Because it's really important that we maintain the integrity of this market. And one of the key aspects of the integrity of the market is that a retirement is only ever claimed by a single individual for a single activity, rather than sort of reclaiming or double counting the same activity over and over again. Okay, so that's pretty much what I had to cover in terms of the NFT strategies. Like I said, if you have any questions about how these integrations work, please feel free to reach out to me. And now I'm going to turn it over to John from Astral Protocol to share a little bit about location-based proofs and how Astral is solving some problems.
Yeah, great. Thank you so much, Marcus, and thank you for the thorough overview of the carbon market. It's fascinating stuff, and it's definitely true that this advanced digital infrastructure has a lot to bring to the effort of increasing the scale and precision in which we're flowing capital into climate impact projects. So it's cool stuff. I may, I think I should take over because I'm going to do
Yeah.
also a little bit of a windscreen tour of our code base. Is that all right with you? I
Yep. Let me
think
stop.
you got to stop and
Yep.
I'll then
There you go.
start. Okay, cool. Right. So, I think we're good to go. Hopefully this is nothing embarrassing. All right, we've got the slideshow up. Great. Okay. So yeah, I'm just gonna take a couple of minutes and talk through some of the work we've been doing at Astral. And this is quite a kind of developer forward rundown of what we're building and some of the tools and software that we're hoping builders build with for part of our challenges that we have sponsored in the Funding the Commons Hackathon. So just to give a very, very brief overview, Astral is an open source R&D studio for the decentralized geospatial web. You can find our website at astral.global, and we're on Twitter and Farcaster under at Astral Protocol. We also have a GitHub, github.com/Astral Protocol. So anyway, the big question that we're kind of perplexed by at Astral is this one here. Where are all the location-based dApps? So much of the internet is useful because software applications use spatial and location data in part of their business logic. This is Uber, this is Tinder, this is Airbnb, this is Netflix, this is Amazon, this is Google. This is so much of the way the web works. And the way we see it, this has been really, really underemphasized in Web3. Ethereum and blockchains are cyber native. They're globally accessible by default, which is really a good thing. But there's a lot that we can do by building tools and software to be able to build location-based services that still adhere to Web3 design principles. And that's really kind of what our entire emphasis is on. How do we build Web3 alternatives to some of the services, platforms, infrastructure that run the geospatial web currently, and also what does Web3 bring to the conversation that can actually improve on the way things work in Web2. And I'll get into a bit of specifics on what I mean by that in a second. But the way we think about this is that there are three pillars or kind of research areas that we're working in. And these three pillars kind of constitute what we see as more or less the breadth of the decentralized geospatial web. Those three pillars are location proofs. This is what I'll put a lot of emphasis in today's talk. But there's also decentralized geospatial data. How do we store spatial data like satellite imagery, like vector tiles, like vector feature sets, like points, lines, and polygons on a decentralized data storage system like IPFS? And then especially, how do we query that using spatial conditions as input parameters? So send me all of the points in this data set that are inside of the boundaries of Paris or whatever it may be, right? And then the third is this sort of much more experimental work we're doing in on-chain GIS, thinking about how we would build geospatial databases using smart contracts so that we can store records that represent geographic features like cities or trees or mountains or whatever it may be, and put that on a neutral, globally accessible, uncorruptible data storage and compute system like Ethereum. So I'll focus in on location proofs first, and then I'll talk a little bit about decentralized geospatial data. These are the two technologies that we have actually built to a position where we think that devs can build with it. So that's why we're sponsoring the hackathon. And then I can talk very briefly or point towards what we're going with on-chain GIS. And if anybody wants to talk about that, I'm more than happy to. So Location proofs are kind of trying to solve this problem that it's really hard to prove where you are or where events happen on the internet. And I mean prove in a more kind of robust way than the way it works now, which is more that we measure where we are using GPS systems, and then we self-report that we're there without any real robust ways of checking that that's actually true. So to try to solve this, we've built a location-proof protocol that is an effort to create a standard data structure or data model to report locations that has all of the trappings of the Web3 design principles I mentioned. So these are user-controlled, these are optionally privacy-preserving, these are cryptographically verifiable, these are composable, these are extensible. And to do this, we use the Ethereum attestation service, which is its own really quite interesting, robust, very versatile Ethereum-based system for creating attestations. What we did is we built on top of that and defined a location attestation. And I'll get into exactly what it looks like in a second. But right now, the location proof protocol is deployed on EAS instances on Arbitrum mainnet, Celo mainnet, and Ethereum Sepolia testnets. And we have TypeScript implementations of client functionality like creating and registering location proofs on chain, and also fetching location proof data. So I'll go ahead now and actually jump into the docs and show you the quick start, which actually shows you how to start building with location proofs. And then I'll also show you some of the resources and code that you can look at to see how we've got it running in a client application that we've built on the location proof protocol, which is also available for anyone to fork and build with. So real quickly, this is a quick start to show how to create location proofs and how to resolve location proofs from EAS. Both of these use the EAS SDK, which is well documented. We've got a link to the documentation. It will be here in 2 seconds after I put it there. We use an EAS config file that is actually something that anybody can pull from. This defines the schema interface, as well as has the EAS contract address and schema UIDs where we've got this registered. If you dig into EAS, this will all make a bit more sense, but we're trying to make this as quick as we can. So I'm assuming you have some familiarity with EAS. To create a location attestation, you instantiate a new provider using ethers and a new instance of the EAS SDK, pointing to the blockchain where you want to register the attestation on. And then you create a schema encoder instance with the string that is specific to the Astral location proof schema. And then there's a couple of values here that I've kind of popped in dummy data, which anybody can add what you want to. And then this is how you encode it using the schema encoder that EAS provides. And you go ahead and register this transaction using the EAS SDK. There's an attest method. Real quick, that will broadcast the transaction and register it on EAS. Then it'll be on chain for anybody to look at, and also for you then to, in the next part, fetch that data and resolve it into your browser or client application to then visualize on a map. So here, same story. You've got to have the attestation UID in this case, and then you can use this get attestation method, and it'll fetch it. And then we've got a little bit of code to destructure and I see a couple of bugs, but to destructure and fetch out all the relevant data. But that will at least get you the data and get you off and running. I made this pretty concise, but you can actually see this code deployed in the wild on the logbook source code that we've built, which here, for example, the attestation page is fetching attestation data. And then here, we've also got the check-in form where we're actually pulling the data from a form that the user input and registering it on chain. So that's creating and resolving location attestations. I know that's super quick, but hopefully that gives you a bit of an orientation of what it takes to build with location proofs. There's one other thing I'll say about it, which is still very much in development, but we think there's no one size fits all for proving location online or on chain. Different use cases have different security requirements, different privacy requirements. And so to accommodate this, we've created an extensible data model where people can actually define what we call location proof strategies. And we've brainstormed a bunch of different types of strategies here. And then each one of these strategies, you'll have to provide some sort of data that serves as evidence that the proof was created and adheres to that strategy. And that evidence can be included in a location proof as well. So when you see something like here, we've got the recipe type and recipe payload. Right now, this doesn't mean anything, but this would be where you'd attach, say, evidence that someone at an event checked you in and signed off that you were actually there. That's an example of a strategy. All right, 2 seconds left on the decentralized geospatial data storage and access systems. This work was done by some friends of ours at the University of Maryland, a group called the Easier Data Initiative. They've got a whole really incredible blog walking through all of the research they've done, looking at how do you store large satellite imagery data sets, terabyte scale data sets on the interplanetary file system. And one of the pieces of work they've done is querying spatial data on IPFS using geohashes, which is a discrete global grid system that segments up the Earth's surface into a series of increasingly precise grid squares. And so basically, they organize the way the data is stored on IPFS using these geohashes, and then you have the option of fetching only the relevant part of the data that you want by querying based on the CIDs associated. So that's about all I'll say on this. This blog post is really thorough and really good intro to it. And then at the bottom of the blog post, they've got a link to their project repository with IPython notebooks, so you can dig into the source code and figure out how to build with satellite imagery stored on IPFS. I'll leave it there, but because I'm conscious I'm probably running up on my 10 minutes. Though maybe just one last thing I will say is the whole idea of this in relation to the climate action track, which is something we really support and a reason we're on this call, is that these things are designed to be the underlying tool set that would help Web3 developers build products that serve climate impact, for verifying climate impact, for monitoring it, for scoping new projects, for automating things like insurance payouts or carbon crediting systems. You know, it's very, very much early days. This is very prototype experimental, but our hope is that these tools mature and develop into things that become really instrumental to working on the climate crisis using blockchains. So just as an example, location proofs were really deliberately designed to be used for monitoring, reporting, and verification providers like the VVBs Marcus was referencing. They go out to a field site, for example, and take pictures of a forest. We want to be sure that they are actually at that forest. They would package up those measurements in a location proof with evidence that they were actually there, and it provides an additional layer of assurance that that's an integrity kind of ecological survey. And then decentralized geospatial data, again, you know, so many use cases, DMRV use cases Marcus was talking about, have satellite imagery needs, and we want that satellite imagery to be stored on durable, persistent, uncorruptible, cryptographically verifiable data storage systems, because as they back higher and higher value financial instruments, there's more and more need to have confidence that that data is kind of what it says it is. So cool, that's it. I'll stop there. Thanks for the slot, Marcus and Teresa, and yeah, really appreciate the time.
Awesome, thank you, John. That was really really insightful, and I think contrasts really well with the demand side integrations that we were talking about earlier. So thanks for sharing. Cool. So we got about 8 minutes left. I wanted to leave a little bit of time for questions. So I'm just throwing up my contact info here and the link to the slides there at the bottom. So yeah, if anybody on the call has questions, feel free to unmute and jump in.
Thank you, Marcus, and thank you, John. John, do you also want to drop maybe your contact information in the chat? Although
Definitely, yeah.
I think both of you are already on the Finding the Commons Discord. So anyone that's watching this conversation from the recording can also reach you out there. And yeah, if anyone has any questions, now is the time. I actually do have one, and I think maybe both of you can answer it. I'm wondering, Marcus, when you were showing kind of the bathtub with the removal and reduction parts, I feel like, all the projects that I've seen in different hackathons, like most like Web3 innovation around carbon, or like climate action generally, is to me focused on the removal rather than the reduction. And I'm wondering, have you seen any initiatives kind of focus on the reduction as well? I'm thinking maybe like supply chain traceability and things like that, that you would really like to see work or that you can already kind of see take off.
Yeah, so one thing I'll highlight is that the reduction versus removal discussion is it's become quite political actually in the carbon markets themselves. So for context, right now, most of the carbon credits in circulation in the traditional market are avoidance or reduction, mostly because those are the technologies that are most mature. So for instance, we understand pretty well how to install renewable energy, how to improve the efficiency of industrial processes, how to protect forests. Removals are sort of newfangled, and the scale, for context, there of those 2 billion credits that have been issued since the carbon markets were created, about 99% of them are reductions. So in the Web3 space, what I think is when I think what you're seeing is that recently there's been a lot of emphasis in the carbon markets on removals for varying reasons. I personally have like a bit of a spicy, controversial position on this, which is that we should reduce before we remove, or like that if I had to spend a marginal dollar, I would rather spend a marginal dollar avoiding putting carbon in the atmosphere than that's already up there. But we do need both, because even if we were to go to emission zero today, we've locked in 1.5 C of warming, and that's going to cause some pretty catastrophic impacts. So yeah, in terms of like in the Web3 space, focusing on reduction, I do think there's an opportunity for some consumer facing applications that help consumers make informed choices about, the products that they're buying or the activities that they're engaging in their lifestyle. For instance, like one of the biggest sources of emissions in most people's lives is transportation. And so just getting people to feel good about taking alternative transportation, whether that's, rewarding people with some kind of reward token for riding their bike instead of taking a bus. You could maybe use location attestations, like John was saying, to, attest to the speed at which someone moved and, show that they're actually walking or biking instead of taking a car. That's a really interesting idea. I've seen some experiments in that vein. But yeah, a lot of the reductions, unfortunately, come from industrial operations. So, in our own lives, like I said, transportation is the big one. Food is number two. So food waste, as well as the choices we make about, eating meat versus plant. Those are the two biggest sources for individuals to change their behavior. But actually, most of the emissions come from industrial sources. So, for instance, power generation and land use change together comprise about half of all global emissions. And it's kind of hard for individual users to think about how they would change, the way power is generated on their grid. Um, but yeah, I'd say the biggest opportunity there in the Web3 space is around basically consumer apps that help people make more informed choices about their own emissions.
Perfect. Thank you so much. Um, we only have a few more minutes left. I'm wondering, John, do you also have anything to share on that or any final words from you both before we wrap up?
No, I mean, Marcus is a font of knowledge, so it's a tiny coloring in the details more than anything. I think he kind of hit the overall nail on the head. Only one thing comes to mind, which is a mutual friend of Marcus and mine, Mark Johnson, is working on a project called Nova Energy, and this is a kind of Web3 play to um, monitor and understand the environmental impact of data centers used for um, Bitcoin mining or blockchain validation, as well as training artificial intelligence machine learning models. And so this is an example of kind of getting a strong handle on what's going on as a critical first step to then reducing the impact and then of the emissions that are really hard to abate or will take longer or be more costly to abate, then carbon credits kind of come into the mix and say, okay, well, we're able to wind down half of our emissions, but there's half that we're still doing for whatever reason. So let's go ahead and buy avoidance or removal credits.
Yeah. Yeah, I love Nova what they're up to. It's really interesting, and it's also interesting to see the convergence between some of the arguments that were levied against blockchain in the early days for its high energy usage and therefore environmental impact, now being levied at AI. And I think it really brings to the fore this difficult reality that we need to balance the value that energy and emissions deliver to us as people with the negative impact that that the energy consumption and emissions have on our planet. Because the reality is, you're never going to hear anybody talking about zero emissions. That is not a realistic trajectory. Like, we're not going to not emit any carbon dioxide or any greenhouse gases. The question is, how do we manage the planet, manage the climate so that we have a stable environment in which to live and thrive, but in a way that we're able to enjoy some of the benefits that energy and emissions have brought to us, whether that's, air conditioning on a hot day, whether that's being able to fly and visit some far off location. There is real value created by the use of energy and the emissions that are associated with them. And so I think it's important to highlight that reducing as much as we can is absolutely imperative, but no one should go around the world thinking we're going to reduce to zero. The question is, how do we reduce as much as possible while still unlocking the value that we all have come to know and love, and then removing emissions that cannot be abated so that we can stabilize the climate and thrive here on planet Earth.
Love that. I think that's a really beautiful call to action as well, and some really difficult challenges to solve. So hopefully we'll see some voters kind of diving into that. And again, whoever you would like, feel free to reach out to Marcus and John on Discord or also through the contact information they shared here. And yeah, we'll be looking forward to the next workshop soon. Thank you,
Thanks,
everyone.
everyone. Thank you, Teresa. Bye-bye.